This is my smart environment monitoring system. It is built using Flask, SQLite, and the Sense HAT Emulator. As we can see, that contains a folder, database, instance, sensors, and services, as well as static and templates. Here I start the application. Yeah, it has also been started. So let's just open this website. As we can see, the system starts a background thread to collect sensor data continuously, like that. And the system runs on localhost, and this is a web dashboard. And the sensor data is simulated using the Sense HAT Emulator. And now let's just move into Raspberry Pi to see whether it can work on the Raspberry Pi and using the Sense HAT Emulator. Let's open the real VNC viewer. This is my Raspberry Pi, and enter the terminal. We can see the smart and monitor and Python app.py. Yeah. Oh, yeah. As we can see, the system collects temperature, humidity, and also the pressure in real time. Like this. The temperature is 25, the humidity is 44, and the P pressure is 1012. And the data is stored in the database and displayed on the dashboard. So let's just enter the website and see whether there is some currently data. Copy. Oh, I still need to enter the username. The username is a default. Username is admin, and the password is admin123. Yeah. Here we can see the temperature trend chart based on the recent data. And now I will simulate an abnormal value to trigger warning. Let's say temperature is really high and the humidity is really high. And you can see here, as we can see, the system detects the temperature exceeds the threshold, and the warning messages are generated dynamically based on the threshold setting. Let's say the pressure is also high. We can see the warning and information pressure is too high from here and from here, and also from the Raspberry Pi 8x8 LED light. So even without opening the web page, we can still see the system status directly on the emulator. So the system also performs basic data analysis, and it detects sudden spike. It detects sudden spike or drop, and also identifies trend in temperature. It can also provide simple prediction based on the recent data. And the system also includes a logic mechanism for access control. We can log in again. And part 3, I'd like to go through the code walkthrough. Let's test the spike or drop. Sudden drop detected, and no overall trend. Sudden drop detected. Temperature may fall below the lower threshold in about 8 seconds. And if we make the temperature higher, you can detect the upward trend. Overall upward trend detected. So even if you wanna change the temperature threshold, and let's say maximum temperature is 60 and the minimum will remain 0. And the humidity is from 20 to maybe 60, let's say, the pressure will remain neutral. Save setting, and setting update successfully. So, and now we can see the humidity is out of range while the temperature is normal. And we can also see that the historical temperature chart, the max threshold has changed on the chart. So let's say the temperature is 83, and say, so the temperature is too high. And that provides basically really clear front-end update and display. So yeah, this is my main Flask application I'd like to show you, which is a application, and it handles routing API endpoints and background tasks. And here's a background worker that continuously collects sensor data. Let's say and valid threshold payload, and this is for the validate threshold, and login required is to check whether the user is logging. So just make sure the security of the code. And here has also some runtime status that will be pushed on the backend, I mean your terminal of your computer. And what is the most important is sensor collection worker. Sensor collection worker is used to continuously collecting the sensor data. And next, I'd like to move to the sensor reader. This module reads data from the Sense HAT Emulator. As we can see, the it is connected with my program, which is called Smart Environment Monitoring.Sensor in the sensor database. So it's abstract to the sensor layer, so the system can work with either emulator or real hardware. So you can either use it on your computer without any emulator, or you can use your Raspberry Pi. So the database Python, I have put this sensor reader into the sensor DB, so we can check the all the database in sensor later. So next we will move to the database.py. So this module handles data storage using SQLite. SQLite is SQLite 3.python settings. So the insert is SQLite 3 and from the typical config, and the warning Python, and the insert and query. And let's see, and the get connection can connect the database with a wrapper, and the create connection is open a new SQLite connection. So let's say the insert sensor data is used to save one reading, and fetch one is to get one row from query. So once your database is full, or your query is it's time to update, you can see it on your terminal or your Raspberry Pi terminal. So warning util is really important in this program. So I think it's a core program because this field contains the core warning logic. So it checks the sensor values against threshold and generates warnings. And this logic is dependent from the UI and hardware, so it can be reused across the system. And the next, I'd like to show you the analyze service. And actually, this module performs trend analysis and prediction. So we can see the safe temperature list is used to get temperature list safely and detect sudden change, and then detect the overall trend, and print some messages and averages, and to show the users whether there's any abnormal message and data. And here this is a prediction threshold crossing. And that is directly how the threshold prediction work. And this is a code that provides this detail. And we can see if the average changes .0 or then it's in a going uptrend, or either whereas it is a going downtrend. So and also you can see some messages in your terminal as well, in your Raspberry Pi. And yeah, overall, the system is designed in a modular way, and each component is independent and reusable, which makes the system easier to maintain and extend. So the sensor database, I'd like to going on because it's really important. Let's see, each reading includes temperature, humidity, and what? Oh, each reading includes temperature and humidity, and pressure is inserted into the database every few seconds. And I want to go through the sensor data. Yeah, sensor data. And we can see that contains sensor's ID, the timestamp, and the temperature, humidity, and also pressure. And since this is only the data I've run on my computer rather than the Raspberry Pi's Sense HAT Emulator, so this is all this stuff of data is made by myself, and manually I pull all the data in, and the database just give you a chart. And the system also stores configuration settings such as threshold value in the database. Like the currently minimum temperature is 0, while the maximum is 40. So do the humidity and pressure has a minimum and maximum temperature, and the value. And the SQLite master is something not that useful, so I'll just skip it. So this allows the system to persist data and reload it even after restarting. So the system also stores the setting table. So the system also works as a data pipeline. But what is a data pipeline? The VS Code. The VS Code. Oh, sorry. The VS Code plus the browser plus the emulator. So first, the sensor reader collects data from the emulator. This part. And this is the data is collected by the sensor reader.py. Then the data is stored in the SQLite database in here, in database.py. So after that, the Flask API retrieves the data and sends it to the front end, just here. And the front end displays the data using charts and warning messages. So at the same time, the display service updates the Sense HAT Emulator. And so the data flows from sensor data backend and front end and then display. So why is this system work? I think this is the main question. So let's demonstrate it. That is because the system runs continuously off the background thread. Let's say the app.py, and we can see the sensor collection worker, valid threshold, the login required, and so this collection data at a fixed interval are stored in the database. It also triggers display update and keeps the system running without using interaction. So this makes the system behave like a real-time monitoring system. So the system is designed in a modular way. Each component, such as sensor rating, database, warning logic, and display, is separate. So this makes the system easier to maintain, test, and extend. Yeah. This is all the thing I want to show you about my program, and this is the end of my recording. Thank you.